right, welcome everyone to our Tech Talks discussion on artificial intelligence. Thank you for tuning in. My name is Caitlin Elphinstone, and I'm the VP of Marketing and Public Engagement at Cayman Enterprise City, and will be your host for today's session. We'd like to start off by thanking our sponsors, Cayman Tech City, who have partnered with Digital Cayman and Kirk ISS to make the ongoing series of events happen. If you have any questions for our speakers today, please send those through the Digital Cayman Slack channel. It's called Tech Talks. Following the panel discussion, we'll have some time for a Q&A session, and we'll read out your questions then. All right, I'm very, very pleased to welcome our accomplished speakers today, and would like to start by going around the virtual room and have our speakers introduce themselves. Tell us who you are, what you do, and how you got into the field of artificial intelligence. So Jack Copper, would you like to start us all off?
Sure, why not? Thank you, Caitlin. Thanks again to everybody who is participating. I'm Jack Copper, Managing Director and founder of Neural Studio, SEZC. So we're a company based in the Cayman Enterprise City Special Economic Zone, although right now, regrettably, I'm marooned in Carnegie, Pennsylvania. Neural Studio pioneered the concept of making advanced neural network technology basically accessible to people who don't have computer science or data science background, but do have data analysis problems that AI could help them address. Neural Studio technology is offered through neuralstudio.ai, which is hosted on Microsoft Azure, meaning it's available around the world. We emphasize a systems approach to applied AI, from preparing data to creating neural networks, to evaluating their quality, and then, of course, most important, to deploying them, putting them in service wherever they can best be used, either in the cloud, on desktop or enterprise, on-premises applications, or even in edge devices like mobile phones or wearables, or industrial sensors and controls. So that's what we do.
Perfect. And how did you get into the field of AI?
Well, I started as a nuclear engineer, but quickly gravitated to software, and I did graduate work at Carnegie Mellon, where a lot of the seminal work in artificial intelligence took place. And that kind of nudged me, or probably more accurately pushed me, in the direction of AI, and then more specifically neural networks.
Fantastic.
It's been a long, strange trip.
Tom, would you like to introduce yourself and tell us how you got into the field of AI?
Yeah, sure. In terms of my entree into the field of AI, it's more of a recent thing in the past few years. I write for Forbes.com, so for that publication, I cover lots of different startups, big companies in the category, so I get to talk to some interesting people. And along that process, I wrote a book on AI called Artificial Intelligence Basics, primarily for those that are non-technical people that don't know how to build neural networks and deep learning systems, but want to understand what they mean and what they can do. And then prior to this, I have a technical background, but not in AI, so probably more practical technical background, because when I started in technology, AI was in a nuclear winter, or AI winter. So I learned stuff that was probably more money-making type activities in those days. And I started different companies, founded them and sold them, raised venture capital and so forth. So AI has been more of a recent thing for me.
Perfect, thanks. Ken, over to you.
I started out life as designing hardware for advanced military weapons. The peace dividend came when Russia fell apart, essentially. And but prior to that, the journey was from hardware to software. So my second job was writing air traffic control software, and I did that for a while, and then I hung out my shingle as a technical architect for large enterprise systems, and the government of Canada consumed my services for the next Lord knows how many years. I was the technical architect for the 38th general election of Canada, and we had developed some really innovative programs like Connecting Canadians. We put in 8,500 free internet sites across Canada, won the Stockholm Committee Gold Medal for e-government, and I got tired of consulting to the government. I had a chance to join a fintech in the Caribbean. I worked for 4 years in the Bahamas, created the all-inclusive island for Grand Bahama with the Ministry of Tourism. Created a plastic card that was the unbanked could transact plastic. From there, I came back to Canada. I worked in a startup for several years, and part of the startup was that we were actually funded to get into emergent technology. We had an artificial intelligence program in our startup to deal with the data, and that educated me into emergent technology. I continued that track, and now I create AI, blockchain, and machine learning solutions for enterprise customers.
Fantastic. And that's at Salt's Technology in Cayman?
That's correct. Yep.
Perfect. Excellent. Last but not least, John, I'm going to point it in your direction. Tell us about yourself and how you got into AI.
So my background is mechanical engineering, and I've pretty much for the last 2.5 decades worked in automation consulting. So that's robotics, level 2, level 3 type systems. And over the years, because we started as kids, we were very interested. My brother actually kind of hooked me on this whole artificial intelligence thing and the sci-fi aspects, and it's always been lingering. And somehow, I guess, well, you could see it in my body of work. There was always some aspect of programming and clever expert systems and things like that that would leak into some of my consulting projects. The last one being for a large engineering company out of the US, out of Ohio. We did some self-guided heavy lift robotics in a steel mill just outside of Pittsburgh. And after that project, I came back to Toronto and started looking into the field of setting up a startup, and I got involved with the conversational AI. And that's kind of where we're at now. We're doing some interesting hardware and software, sort of along the lines of Ken. And yeah, very exciting field.
Yeah, we're excited to talk about that a little later on in today's presentation. Perfect, but I think we want to start off with kind of explaining AI. As with every other new technology trying to find its place in the world, there are a lot of buzzwords floating around. Machine learning, big data, deep learning, neural networks, even the term artificial intelligence itself is a little unclear. Jack, can you shed some light on what some of these words mean and why they're sometimes used in similar ways and sometimes not, and generally help us to get a better understanding of AI?
Sure. But I'll start out with pointing out that you put four AI experts in a room and you get 6 explanations for what AI is. So with that caveat, sure, let me comment on a few of the buzzwords. Big data is one that actually has always kind of irked me. Yes, there's a lot of data in the world. Yes, the amount of data is growing. Yes, artificial intelligence requires data, even requires a lot of data. But the phrase big data, I don't think it adds much to the conversation. So let's get rid of it. Machine learning, on the other hand, I think is a useful and oftentimes even a more appropriate term to apply to what is often called generically artificial intelligence. Early machine learning involved actual physical devices with gears, with camshafts, with other mechanical components. Today's learning machines, of course, are computers. They're devices, but the learning, the activity basically is switches, so everything is silicon-based. But in the end, machine learning, I think, is an appropriate term and arguably can be used pretty interchangeably with AI. Deep learning, another currently popular term, it basically refers to what started in the 80s as neural networks. I think that deep learning sort of came into the vernacular basically because as computers got increasingly powerful, more powerful, faster, neural networks got larger, meaning they had more internal components. But in the way of all technology, since neural networks were 1980s technology, people needed, academics in particular, needed a new term. And so rather than saying neural networks, they began to say deep learning. But in the end, current neural networks or current deep learning, again, for the most part, are the same things. And you drill down into any description of deep learning, and at the bottom you find, yes, those are neural networks. With respect to the term artificial intelligence, I think first I want to highlight a few, if you will, attributes of natural intelligence, human intelligence, and do that by way of a few highly selective historical events. First, one pretty broadly agreed upon component of real intelligence is language. You know, humans develop language. We express abstract ideas, like, for example, intelligence, through language. And language allows communication between entities that purport to be intelligent. A second pretty broadly agreed upon element of intelligence is learning, or the ability to learn. Early human learning, without a doubt, is trial and error. You know, until humans learned that when the ground started shaking, they better get out of the way. Some humans didn't make the cut, so to speak. But the power of learning is when an entity that has learned something about a set of stimuli, or in the case of now current day AI, we call those stimuli inputs. When that entity has learned and is then later presented with a set of inputs, it knows, and those inputs are not exactly the same. That's a critical distinction. It knows how to respond to those inputs. And the subtle distinction is that learning implies generalization, whereas memory is not generalization. Things that have only remembered something haven't learned. So the evolution from natural to artificial intelligence really began about 80 years ago. A couple of guys, McCulloch and Pitts, a statistician and a biologist, basically looked at rat brains and concluded that what happens in a brain is that electrical impulses from a bunch of neurons combine in a target neuron, and that neuron either fires or it does not, meaning, translated to today's AI, zeros and ones in computers.
Great.
Jumping forward to 1950, there was a crude idea of what constituted or what went on in brains, rat brains as well as human brains. And thanks to Alan Turing, a mathematician, a British mathematician, he came up with what's now called the Turing test, a way to distinguish whether something had intelligence. Fast forward a little more and skipping an awful lot of history, the term artificial intelligence was basically coined in 1956 by a guy named John McCarthy when he convened a summit at Dartmouth College to explore these new ideas of artificial intelligence. A few years later, the basic structure of an artificial neuron was invented. It was called a perceptron. And although it had a fundamental theoretical problem, which I'll come back to, it really is, or was, the foundation for everything that we now consider is artificial intelligence in terms of how computers began to act intelligently. From the 70s through the 80s, that theoretical problem, which was that a perceptron could not solve the XOR problem, that was solved by the realization that if you put a bunch of perceptrons in layers, then they can solve the XOR problem. And that led to basically what we now call neural networks, collections of artificial neurons that in some way can exhibit intelligence. Now, I should notice that in that, Tom mentioned the AI winners, several of them have occurred. The first, though, high level of interest, sort of went into the early 90s, where because of the universal approximation function, it was demonstrated that neural networks could basically solve to any required arbitrary degree of accuracy a wide range of basically continuous valued functions. Now, I should also note that during that era, there were lots of other kinds of, quote, AI technologies. Herb Simon and Alan Newell developed production systems. There were systems based on the Lisp programming language, expert systems, which are basically rule-based. But also note that the neural networks developed in the 80s are structurally the same as neural networks or deep learning that are in widespread use today.
Fantastic. And I know that you and Jamal have been working tirelessly on release 2.0 of your Neural Studio portal, and you were recently granted a US patent related to AI. Can you give us a sneak peek of what's in the works and how your patent fits in?
Sure. When we started building Neural Studio AI, one of the first things, of course, we did, even though I'm not much of a marketer, was what's the tagline? And that turns out to be AI creating AI. We wanted to make it easy for people to basically be able to build and use robust neural networks. And the only way we could do that was really to apply some of the AI that I happen to have in my AI toolkit. So we did that, and I'm pretty happy with the basic flow of the first generation. I think it is easy to follow. But as we basically put it out in the world and got feedback from people, a couple of things happened. We realized that having even more options for preparing data was important. We realized that more visual presentation of what the neural networks were doing, making that available on the site, as opposed to reports that you have to look at, that was important. And perhaps most importantly, this idea of moving intelligence to the edge. Everything that's built now in Neural Studio AI can run anywhere. The neural networks can run in small devices, but the process is really not as smooth as it needs to be. So we're putting a lot of emphasis and work into that.
Fantastic. Well, we look forward to seeing how that all rolls out. I'd like to move on to Tom, just so that we can circulate with all of our questions that we have today. One of the biggest issues with AI is control or lack of control. In other words, what are examples of how technologies has gone off the rails, and what are the actions that we can take to minimize these risks?
And thanks very much for having me. This kind of goes under the umbrella of what is known as responsible AI. It's a term you're going to hear more and more in the years to come, and it's about the impact of AI on society. We all have smartphones in our pockets. We talked about the AI winter, and Jeffrey Hinton is one of the great minds of deep learning and AI, said that we're never going to have a AI winter because we all have smartphones, and they have Siri on it, and they have Cortana and Alexa, and we have Alexa devices. We're not going to, the horse is out the barn door. So the fact is, AI is here to stay. It's not going to retract. You can't do that with technology. But AI, because it is so ubiquitous, is going to have major impacts on society. And it's not necessarily the Frankenstein or Skynet, Terminator type things. Now, there are bad players out there, but the interesting thing is, I think the bigger problems, because we have security companies that can deal with stuff like that. I think the big problem is that the problems that emerge that are unintentional problems, that are with bias, or the fact that many data scientists are men who are white. And certain outcomes are going to be a certain way because of their cultural way of looking at things and how they look at the world. So a great example of this happened last year with the Apple Card. They teamed up with Goldman Sachs to have their own credit card and debit card and so forth. And they had this huge rollout. Obviously, some of the brightest minds in finance and brightest minds in technology. And what happened? Well, what they found out was that all of a sudden on Twitter, things started to emerge, and people were getting really angry, saying, I'm a woman, and my credit limit was a lot lower than my husband's credit limit. And then there was a case with Steve Wozniak, and his credit limit was much higher than his wife's, even though his wife made a lot more money than Steve made. It just created this whole brouhaha, and people would call Apple and say, what's going on here? And Apple said, well, it's just the algorithm. And, for a customer support situation, that's probably not the answer you want to hear when you're in that predicament. So, the folks at Goldman and the folks at Apple, weren't intentionally looking to make sure that women did not get higher credit ratings. It just happened that they built algorithms and they had data sets that led to some of that in their outcomes, and it resulted in a very bad situation for Apple. And I think that is the harbinger of things to come and things that we need to be aware of. Now, in terms of how to deal with that, I think, one, we need some more diversity within these companies, and I think there are some moves in that way. More education. I also think it starts at the top. Companies at the C-suite level have to put in policies to look at bias, to look at responsible AI. And we're already seeing that with Microsoft, and recently when the different companies like IBM came out against facial recognition for certain use cases. So big companies are going to start moving this direction because they don't want to be caught off guard like Apple did. And so this is an area I think that when it comes to AI, we should pay more attention to.
Very interesting. And you're the author of a new book called Artificial Intelligence Basics. Could you share some of the key takeaways with us?
Yeah, thanks for bringing that up. Through my writings with Forbes, I've talked to, like I said, a lot of founders and CEOs. And what's interesting, even they, who you think they'd be experts in AI, have different ideas of what AI is or what machine learning is. As Jack recounted, and this is a complicated area. And if the experts are not necessarily in agreement, how's the rest of us, who are not technical people, going to evaluate this technology and understand it? Because if AI is going to be effective and advanced, we can't have it be something that is clouded and opaque in a black box. That only creates fear and uncertainty, and that's going to lead to problems with the technology. So the idea with the book is, if you're a non-technical person, you don't necessarily know what a deep learning system is, but you're interested in knowing what it is, this book will show how, and it just goes through the different types of things, and then from a little of the history of the AI, the different concepts of AI, and then at the end, some more about the ethics and the responsible AI components.
Interesting. Sounds like I need to get my hands on a copy of this book. Ken, this next question is directed to you. Artificial intelligence seems very exotic and out of reach for many businesses. Is this true? And most importantly, does AI have the potential to help businesses recover from the COVID-19 pandemic?
Oh, absolutely. One of the biggest problems with AI is that it has this aura about it. Some really wicked memes. A lot of newspapers have reported that both Stephen Hawking and Elon Musk have said that we should be afraid of AI. That's not quite true. It's sort of fake news, because what Hawking actually did say was that we should be aware of the risks, or we should be afraid of risks that we don't know. And of course, Elon Musk, in his bombastic way, said that if AI has a goal and humanity stands in that goal, AI will have no compunction of destroying humanity with no hard feelings. That is true too. But AI as we know it today is simple and useful. And I know that that's like an oxymoron, but by simple, what I mean is that I'm a coder. So when I create an AI machine, I don't have to code in rules. I don't have to code in logic. I don't have to code in. I make a black box with some artificial neurons and I throw data at it. It comes up with an answer, and the answer is really stupid. I give it a slap and tell it to correct itself a little bit. And now, mind you, the math to give it a slap and correct itself a little bit is a little bit horrendous. But after, they're called epochs, training epochs, and after a few million epochs, it becomes useful. Somewhat useful. And so this is why, I mean, normally business people who have no concept of what AI does, or think that it's this big, weird, and wonderful thing, they're totally unaware that they can use it themselves now in their business. And the way they do it, it's become a commodity. And a good example is storage. I remember back in the day with my Windows 95 machine, I would bought a gigabyte drive, and I paid almost $1,000 for it. And I spent half a day trying to make additional storage for my computer. I had to set up the ports. I had to set up the serial port. I had to format it. I had to partition it. Had to get the right drivers. And now you just click on a link and you have storage has become a commodity, and AI has now become a commodity. Some of the leaders are the Microsoft Azure stack, which I work with, but also there's the AWS, Amazon, there's IBM, and there's a whole lot of different conceptual areas of AI, like you've heard, deep learning. Deep learning is used for generating music or images or self-driving. Different kinds of AI is used for classifying things. Like you have a big data set and you can classify, you can automagically just throw this data at it and get it classified. And the real good example in quality control and manufacturing is looking for dead mice in empty beer bottles that are returned for filling. You get free beer if you find one. That's another. But the most interesting one, and the one that I'm interested in, the one that it will help business is, Jack alluded to it, it's natural language processing. And Microsoft and IBM and Amazon and everything have trained AI engines. They spent thousands and thousands and thousands of hours and millions of dollars to create a machine that recognizes words in a contextual fashion and in a meaningful way of going through data and figuring out where they are, what they are, and what they do. This is called cognitive knowledge mining on unstructured data. Everybody has unstructured data, emails, essentially anything in your documents. Even if you put out newsletters, restaurants have menus. That's unstructured data, stuff that normally is not tagged and you don't have easy access to it. There's also structured data, and that's stuff in a database. But cognitive knowledge mining and AI will allow you to mine that data as well. Now, how do you use it? Because of the simplicity of the way it's manufactured, or the way it's done, is that you sign up for a subscription, fill in a wizard, show it where your data is, and a few hours later, you have what's known as an inverted index. That means all of your data is logically searched. Key pairs are made so that it can tag it, and it's all done. You have a really good estimation of what's in your data, and then you can download that into something like an Excel spreadsheet. And once you have it in an Excel spreadsheet, the path to knowledge mining is that you take raw data, and tons of it. You integrate that data, cognitive knowledge mining, into information. And then the last step, it's all integrate, and you integrate information into knowledge. And so that's essentially it in a nutshell. It's all in the cloud, very low code for the basic stuff. Now, mind you, if you have really exotic needs, you need to hire a geek like me to make little skills for you, but that's not a big task. And it takes business intelligence to the absolute next level. And business intelligence means you have an edge on your competitors, and you have a way of getting ahead. And that's the type of AI, the commodity of AI that we have now, and it's a readily.
Thank you. That was really informative. Thank you very much. John, this question's for you. So COVID-19 has highlighted not only a lack of worldwide preparedness, but it has also highlighted the social wellness effects, isolation, loneliness, etc., as well as serious cognitive impacts to pandemic survivors. Do you see a place for conversational AI operating at scale and tackling these global mental health challenges?
I do. I suspect there's a shadow stigma about visiting medical facilities. I've seen something that says ER visits are way down, and seeing your mental health professional just sort of layers on top of that, doubles it up. Then you roll into, employment issues, financial stress that a lot of people are experiencing, and you start to see like this heady mix forming. And before the pandemic, we were researching that there's a tremendous amount of a large portion of the population has no mental wellness support. And this is sort of our driving motivation behind the safe spaces. We want to bring support into everybody's hands, so it's like within reach. You just grab your phone and you connect to a conversational AI and have that conversation that you might not be able to have with a clinician or a best friend or even your general practitioner, your doctor. So that's I think this is a perfect storm in some sense, and I see conversational AI really scaling up to kind of meet that challenge.
Mm-hmm. Interesting. And your Loonshot project called Safe Space, that sounds really ambitious. Tell us more about how you're fusing privacy by design, AI ethics, wisdom of crowds, and a new model of employment into the AI mix. Tell us more about this.
So the Loonshot idea is because we're crazy. We're doing something for mental health, and we're crazy. But I'll start with the privacy. So we've based our architecture on privacy by design. It starts at the fundamental level. Without this foundation, we think it's very unlikely people will actually use our safe space. There's an interesting article in the New York Times just recently about another company called Talkspace, and how privacy was violated in a similar fashion. They use text messaging to psychologists, and how the actual transcripts of certain sessions were breached. So you could see just the sense in the article, like the dismay and how egregious this breach was. It's a common problem, this privacy issue. You're seeing it across other like social media platforms as well. And I'm certain everyone's going to agree that your mental health conversations should remain private, especially when you're with an AI. And that reaches into what the gentlemen have explained about the deep learning and the machine learning, that touching that data has some implications, not only say from an ethics standpoint, but also from potentially a bias standpoint. And there's a lot of overlap there. Rolling into the AI ethics side, there's complex challenges, and conversational AI and mental health, this just sort of complicates it more because there's things like HIPAA requirements, PIPEDIA here in Canada. And we're sort of steering towards using the European Commission's Guide for Trustworthy AI. They have 7 guiding requirements that we're trying to digitize into our platform. They are human agency and oversight, technical robustness, privacy and data governance, obviously, transparency, which is a big thing that a lot of big tech companies don't give about what they're doing with your data, how they do certain things, because they're keeping proprietary knowledge and technologies to themselves. There's a diversity and non-discrimination and fairness issue that's a requirement of society, and the overall environmental well-being, as has been pointed out previously here. And then the overall accountability, like who's going to take responsibility when you have an AI helping people through their anxieties, through their depressions, just through their day-to-day up and down, feeling the blues today, but feeling better tomorrow. That has a lot of AI ethical implications that have to be addressed, and we're trying to do that with some framework. And like I said, the European Commission is doing a lot of interesting work there, so we sort of chose them as our guiding light, our northern star, so to speak. The wisdom of the crowd is actually a very interesting aspect, and this is not my idea. This comes from a brilliant gentleman who will soon be installed as my CEO. He brought it up, that tapping into like a collective wisdom of a sizable group of diverse people actually can lead to better outcomes, like better than the average usually. And we're thinking that if we're able to achieve an above average conversational AI and within sort of the mental wellness, mental health expertise domain, then we probably are looking at something quite substantial, something quite disruptive. So wisdom of the crowd is an interesting concept when applied on top of AI, because I think that also gives some of the issues that people feel uncomfortable with. It gives them a touch point, a direct touch point into something like this. So it's a big experiment, and it goes with the Loonshot theory that we're going to try something crazy, but who knows, it might actually work. And then this all flows into like the final piece of the madness is because we're using wisdom of the crowd, as we're turning it into a work opportunity, because we're opening it up to anyone. We're building this on top of LinkedIn, actually. So anyone can contribute to, helping with the edge cases in the conversation, but not seeing people's transcripts. That's a no-no territory, but actually just helping evolve. And I think the statement is, it takes a village to raise a child. So it's in the same sort of concept. And we take that a step further. We look at the contributions that people will be making and rewarding them in a cryptocurrency. That's the only way we see doing this in a global fashion. So we're hoping to get like a global workforce, take care of the diversity issues, and actually create jobs, meaningful jobs, like jobs that actually have an impact on society. And I think this compensation framework really creates a fairness that only an egalitarian would love. So that's kind of where we're headed.
Oh, that's fantastic. That's really great work. So now this next segment of today's discussion is some questions from the audience, from our viewers. So I'd like to start with this question that Joanne sent through, and Joanne has directed it to Jack. She says, Jack mentioned AI wearables. Can you explain a little bit more about that?
Yeah, the basic sort of high-level concept is that the closer intelligence is to where the data is, arguably the better decisions get made. And so when you look at things like Apple Watch and the sensors built into that, or any other device that's close to you, including your phone, if that contains intelligence to act on the data, then you've got arguably a better shot at making better decisions. So if it's in the case of a phone or some other special purpose device, one carried by somebody who falls, then sensors inside the phone or the device can basically detect that odd type of behavior and do something like call an authority or a medical a caregiver. So, actually, I attended a seminar yesterday where a company postulated that by 2025, 80% of the data generated in the world will be processed by edge devices. So, yeah, I'd like for Neural Studio AI to be embedded in some large proportion of those devices and help make those decisions.
Mm-hmm. Interesting. All right, the next question is from Deval. They say, what are some of the resources available online for learning AI, and how can a beginner get started? Does anybody have any recommendations?
There's Ken. Hi. There's several courses. There's several beginning tutorials in AI. If you're not a coder, there's several AI for dummies. But if you want to play with AI and you have a basic idea, but you don't really want to, you can sign up for a free Azure account on the Microsoft Azure stack. and you can actually play with it and do the tutorials. They have an excellent online knowledge base, and you can get your feet wet by actually doing it, trying different things, and it's that easy. It's that easy. But I would seriously suggest Tom's book on AI, and just to get the basics and get this stuff down pat. But there's lots of almost everybody who puts up an AI framework that coders can use. They have an online demo. Play with it.
Yeah, and let me interject that Neural Studio, you can do exactly that. No charge, not forever, but for free. And see, we provide a couple of dummy data sets that you can play with. So you don't have to go to Microsoft.
Jack, your code runs on the Microsoft Azure stack.
Busted.
No, actually it doesn't. It runs on Microsoft Azure. Yes.
All right. Well, the next question that just came through is from Thomas. They say, where do you see the biggest challenges in recruiting excellent talent?
In terms of recruiting right now, it remains one of the biggest bottlenecks for just about anybody. We've seen examples of, Uber a few years ago raided Carnegie, when the salaries are so high in the private sector, it's very difficult for someone to go through these PhD programs in artificial intelligence and machine learning to really build up these skills and these muscles and so forth. So the money's kind of an issue here. But I do think with products, like what Jack was talking about, his products, and there's the auto ML products that are emerging, like Data Robot and so forth. You may not necessarily get someone kind of off the street to start creating AI, but maybe someone with some technical background and some data analytics background, or maybe you can train them for 6 months to a year to get them to the point where they can start developing some interesting things. So I think companies are getting very, very creative with this, not necessarily getting a PhD or an expert, but maybe doing some internal training through some of these online courses, and then using these auto ML systems to get up to speed and getting to AI faster.
And to follow on that, what extent do you predict that AI will be replacing jobs?
I think it's already been replacing some jobs. I think we're talking about the NLP discussion. These models are just. There's like 100 billion plus hyperparameters in these models that are created for NLP. They're just staggering. The thought just a few years ago that when you had that many parameters in a model, it just won't work, and apparently it actually does work. So I don't think massive job loss is anywhere in the near future, but I do think over the long term it will happen. There's still things that these models can't do. Wall Street Journal had a really good article about this, about these NLP models, and that is they still are not really good at reasoning and logic. The old SAT questions we used to, here in the United States, we had the SAT for college entrance exams. They would have these kind of weird questions, and they're just trying to figure out, do you have the ability to reason and to think things through? And still, AI is not quite there yet, and it's probably going to take some time. But when it does, I do think it's going to probably be scary time for people's jobs, because then we're going to, the white collar people, the attorneys, even doctors. I talked to someone who said, a regular doctor will probably lose his or her job before a nurse, because a computer will probably take a lot longer to figure out how to interact with people versus someone who just knows what drug to prescribe.
Interesting. I've got a question from Fieka. They say, what would you say are the common misconceptions about AI? And I'll open this up to anyone who wants to answer.
I don't think that AI is really good at a single task. It's not good at broad range tasks, so that you and this is where you got these newspaper memes that AI is going to be really, really dangerous and it could destroy us. I mean, it still could, but it's not as smart as people think. And the other thing about AI is that it's really, really good, but it's not robust. I'm doing some research and doing a patent on defeating facial recognition. I'm really angry at the way privacy is being. You could be walking down the street in London, England. You from Georgetown or Jack from Pittsburgh, and if you're on Facebook, there's a company called Clearview AI. They've scraped over 3 billion pictures, and the London police can identify you from their CCTV cameras. But luckily, and my research shows that it's very, very easy to defeat. It's called the pixel adversarial attack. So it's AI. It's easy to get around. It's good, but it's not really, really robust yet. So it's not the all-knowing overlord. It's good at specific tasks.
Does anyone else want to comment on common misconceptions?
Well, not so much a misconception, but an observation. So a pretty smart guy named Ray Kurzweil, who works for Google, has predicted very publicly that by 2029, computers will equal human intelligence. So a point I wanted to make was that right now, humans still direct AI. So AI, as Ken basically said, AI can solve specific problems fairly well, fairly consistently, but it's still humans that define what the problems are. So Kurzweil is saying 2029, computers will be equal to human intelligence. So in my language, that means computers will start defining the problems. And then he says in 2045 that human intelligence and computer or artificial intelligence will merge without, to my knowledge, him really saying exactly how that merging is going to happen. But my basic point is, yes, right now, humans define the problems, AI goes off and solves them.
Ray Kurzweil is a god. I read his book, The Age of the Spiritual Machine. And my kids gave it to me for Christmas, and it was remaindered, so they bought it cheap, even though it was a $30 book. And I'm reading through this, and I'm saying, this is bosh. It was exactly what you described, Jack, by 2029. And so anyway, I read through it with a highly, highly skeptical view. But it had an appendix of 3 pages, how to build an intelligent machine with 3 easy paradigms. I opened my software development kit and I started coding right away. And Ray Kurzweil, for me, is a god.
All right, we've got one last question that we're going to read off today. It's from Joanne, and they say, how do you see AI in healthcare? I know we touched on it a little bit, but does anybody want to expand on that?
Broader picture of healthcare or a more specific, like?
How do you see AI in healthcare? Maybe in relation to the COVID pandemic. Do you have any thoughts there?
So they're using a lot of AI, machine learning to work on COVID-19 vaccines. And I find that interesting because before that, we're using AI to do drug modeling, to go through basically brute force and find different combinations of drugs with different, speed up the chemist in the lab. So when it comes to healthcare, I know Jeff Hinton said that if you're a radiologist, be out of a job soon because they have the ability to pick tumors off of an X-ray, like a mammogram and stuff like that, with a higher precision than specialists and doctors. I think the impact is going to be great. I don't think they're going to get rid of doctors. I'm going to vote on the other side of that. I think you'll always need doctors. I think doctors will become better doctors because they'll be augmented with AI, but they'll still make the final decision. I don't see jobs in healthcare being that greatly impacted. I think healthcare is a field that has a lot of room to expand with AI, because I think personal health is sort of the next big frontier. And I think if you talk to, Ray Kurzweil is a good example. He's one of these health fanatics and life extension sort of individuals. And I think when you start looking at personalized medicine, and like in our case, we're focusing on mental wellness, not just mental health, but mental wellness, because everybody's got their up and down days, and there's so many dimensions to that. So the impact to healthcare in general, I think, will be profound. I think there'll be a cost savings at some point, although I think there'll be a lot of profiteering at other rally points in certain jurisdictions. But I think overall, healthcare wins. I think actually legal also wins. I think those are two big fields that win with AI.
All right. Well, before we wrap up today's discussion, does anybody have any final thoughts that you'd like to share with those who are tuning in?
I have. Everyone has these motivational posters and everything. And there was an AI machine that was programmed to create motivational posters. And this is the best one that I've seen come out of AI. And it says this: new ideas have been invented to be destroyed by ambitions.
Well, on that note, the recent, I think the most recent question about the impact of AI is that a computer scientist submitted a patent application in the name of an AI that he, quote, created. So the inventor was not the computer scientist. The inventor was Dabus, D-A-B-U-S, the AI that created an invention. And the U.S. Patent Office rejected it because a patent must have a natural person as an inventor, at least under current laws. And I just read this morning that the computer scientist has now basically filed suit saying that the U.S. Commissioner of Patents did not have the right to reject patent application because it was submitted by an AI. So I think that's raised a whole host of interesting, shall we say, questions about what is intelligence, and can artificial intelligence invent something? And the more fundamental practical question is, who owns the rights to that invention, or in the future, other potential inventions? So stay tuned.
Any other final comments before we wrap up today?
This is for all the kids in high school. Learn tensor math. You'll be okay.
Absolutely. Tensors.
All right. Well, thank you very much to our speakers for your thoughtful insights. And for everyone who's watching, please do continue the conversation online on the Digital Cayman Slack channel. Cayman Tech City and Digital Cayman are on a mission to support Cayman's growing tech sector, so please do get involved. You can visit digitalcayman.com for details. And finally, a special shout out to Kirk IFS for assisting with our technical support today. All right, that wraps everything up. Take care, everyone. Thanks again, and we'll see you next time.
Thank you.
Bye-bye. Thank you.